Okay, folks, we're gonna get started here. Wow. Let's see if we can pull up. Things here. All right. Let's do this. All right. Hello, Bellum. I will need your help so much today, I think. You are first, by the way, in case you're wondering. But thanks for dropping by. Okay, so here is part. I can't say the name because I'm so nervous. Project Euler. And we have our first problem. This is actually problem number 1. Oh, yeah, because I changed to my quote unquote real username. So I used to be, anyway, something else, but I'm not anymore. I'm actually Vintage Luigi, like, for pretty much certain now. Yeah. We collect oil. No. Let's see. So this looks like it should be easy because I'm thinking about a way to do the problem. Unfortunately for me, it does not work. So okay. So here's what I'm thinking. Um, yeah. Thank you. Yeah. So I actually got a scientific nickname in high school. The dollar signs are for math type, and I don't think it's quite working. But let me try to make it work. Let's see if this 3 will actually end up being what do you call it? Rendered. Yeah, all right, that's cool, but that's not what I want. I don't know why it doesn't like render it itself. It should. I shouldn't have to put parentheses everywhere for this thing to render correctly. Like it should be its own thing. I don't know what Project Euler people are thinking, but hold on. Let me add a bunch of sort of like formatting tags here. And then I'll start working on the problem, which actually is theoretically pretty easy, but I did not get the right answer the first 2 times already. So, yeah, let's try this. Okay, so oops, the 10 is still in. 10 is still between dollar signs. It's not good. Whoops. Okay, so yeah. The reason there are dollar signs is because those are supposed to be math type. So instead of 10, we can put 10 sign of, I don't know, what's a good thing here? Theta, and then we can make a fraction too. It's LaTeX or LaTeX, depending on how you want to pronounce it. But yeah, let's see how we do here. I'm a pure mathematician. Warning here, I have no idea. Or not. I don't have very much programming background in the classroom, so I apologize in advance. But here we go. So yeah, so now it says we list all the natural numbers below 10 sine theta over 2 that are multiples of blah, blah, and it looks nice. That's the point of the dollars. Prize. I don't know. I'm not in charge of the prize department. I'm in charge of the let's make, Luigi not look too stupid department. But anyway, all right. So here we go. So here's the question. So I'm coding this in JavaScript/HTML. Let's make a little extra div here. This extra div will be given the ID of out for output. And yeah, let's go back to the script tags and window dot unload equals a function that I am now going to define. A function The first thing we want to do is, well, before that, we should make a variable called out or outer or output or out something. Outs with a Z. Okay. And after the window loads, we want outs to equal Are you ever sleeping, you know? Because, like, I see you on all the time. Get elements by... Are there, like, a bunch of you? I'm probably not going to show code today. I just don't want to mess with it. Like, I could. Nah, I don't... I'm not going to... No code today. I'm just going to, like, talk and show you the results and some of the intermediate steps, probably. The output. But anyway, okay, so this would be get out. So then we can use outs anywhere. And we'll, under window.onload, after we define outs, we can just run the function that does the calculation. So we'll call this calcit. And we'll make a new function called calcit. And hope that that does something good. For example, outs.inner HTML equals out. Okay. Let's put an HR thing between the div and the problem statement. That would make it nice and pretty, sort of. And let's do this. All right, I have a function that outputs out. Okay, cool. Okay. Do you want me to show you the code? I'm not sure I'd be very proud of this code. I'm not a... I'm not... Yeah, anyway. Okay, so right now... Let's see... Actually, we can even do this. .inner.html. I wonder if that'll work. So I'm going to make the variable the inner HTML and see if this works. Just to make sure before we start... Ooh. Doesn't like it. Doesn't like it at all. Okay. Yeah, okay, can't do that. Drat. That would have made it much easier. So okay. You know what we could do? We could do another function called oh. Should I do that? Let's try it anyway. We'll call it logs with a Z. And that will output stuff to the page. So, in text, we'll add that to in text plus a BR. Okay, let's see if this works. Let's log out, log out too. Let's see if this works. Go. Yeah, alright, so I got basically like a logs thing. So I got console.log, but onto the screen. Alright, cool. This is good. So far, anyway. Okay, so now let's actually try to solve the problem, which is, I thought I had it. I could do this one by hand, sort of, kind of. I want all multiples of 3 that are below 1,000. So how many multiples of 3 are there below 1,000? There are 333. And what I want to do here is add up all the numbers from... Yeah, I want to say that works. Okay. So I need to add up all the numbers from 1 to 333 and then multiply by 3. That's what I think I need to do. So, you know, arithmetic sequence. 1 plus 333 times 333 divided by 2, all of that times 3. So that should give me what I need. And now I'm cheating because I'm going to use a calculator. But I haven't coded anything, which which is sort of cheating in itself, I guess. 333 times 334 equals divided by 2 times 3. So I got 166,833. Okay. Now I do the same thing with the multiples of 5 and then subtract the multiples of 15. That's what I think I'm supposed to do. So let's try with the multiples of 5. Oh, it says below 1,000. Oh, I included the 1,000 one. Huh. Now I'm curious if I can... No, let's just go through the whole thing again. All right. So below 1,000 would be not 200 multiples of 5, but 199 multiples of 5 times 200 divided by 2 times 5. Okay. So let's try that. 199 times 5 times 100. 99500. So let me put a semicolon here. 99500. Okay, and now we got to do the same thing for all the multiples of 15 because those were double counted. And subtract them through. Oh dear. I don't know what that does, but I'm scared. Okay. Is my OBS hacked? I'm confused. Okay, so the next thing is 990 is the highest power, not power, multiple of 15, less than 1,000. So I need my 990 divided by 15. So there's 66 multiples of 15. So I'm going to do 65. Oops, no, just kidding. 66 times 67 times 15, all of that over 2. So let's try that. 66 times 67 times 15 divided by 2 equals 33165. So let's put that also here on the paper. 33165. Okay, cool. So if I did this right, I should get a number. Let's make this negative. Negative. And then add 995. Oh, okay. And then add 166,833. 233168. That's what I got. That is exactly 1,000 less than what I got before. Oh, I see. I see. I'm not doing any coding yet. Hold on. This is the first problem. I know how to do this like on paper without too much for loops or anything like that. So I think I can get this one. I think. This is what I think is the answer without doing any computer work. Check. Please go. Yeah! All right, I got one right finally. All right, cool. Just a little bit more confidence now. Okay. Okay, so that's the first problem. Let's copy the second problem. The second problem is about Fibonacci numbers that are even. Okay. Okay, let me copy down the, what do you call it? The, oh dear. Oh, okay. Copy down the problem. Let's save this. Let's resave it as Euler that. Okay. Oh, wait. Oh, okay. No. I'm confusing myself. This is bad. All right, let's paste in the problem now. And let's do some of this. Well, I don't need to do that. Oh. Wait, hold on. Let me check the problem originally because it's giving me weird formatting stuffs. Oh, it does that. Okay, cool. All right, cool. We're good then. I'm going to leave the dollar signs alone because it's not that important. Well, all right, fine. I'll do them. Okay. Oh, the answer to the first question was, let's see, where'd it go? I wrote it down. 233168. That's for problem number 1, the one with the multiples of 3 and 5. Would you like to know how I got it? I didn't even have to code a for loop or anything. It's fun. Okay, so oops. Go back. Basically, you find all the multiples of 3, 1,000 and below, and you find all the multiples of 5, 1,000 below, and you add them together and you subtract the multiple of 15, 1,000 and below. And that's basically what you do. It's pretty cool. Yeah, I'm sorry, but ChatGPT is not correct. I got a green check mark for that one. I'm pretty sure I'm right. All right, let's see. Let's reload this page. And here we have the second problem. Sorry. All right, so here we have the second problem. We're looking for all the Fibonacci Fibonacci numbers less than 4 million. No, less than or equal to 4 million. Wait. Yeah, less than or equal to 4 million, but only the even ones. Okay, so let's make a for loop because I don't want to try this without the computer. Okay. So calc it. Let's see what we can do. We should probably use a while loop. Yeah, all right. No, I just use a for loop. I don't care. I really should use a while loop, but I don't care. Sorry. And then I'm gonna like okay, so I'm gonna have two Fibonacci or two variables for this. We'll do x and y. So x equals 1 and y equals 1. Let's start with 1, 1, even though it doesn't really matter. But yeah, we'll just start with 1, 1. So z equals x plus y. And then we need this thing called the sum. Sum equals 0. Okay, so z equals x plus y. And z equals x plus y. What am I doing here? Okay, so if z percent 2 equals 0, sum plus equals z. Okay, so far so good. Actually, technically I should check to see if z is greater than 4 million it was, I think. If z is greater than 4 million, z, let's make a double thing here. Z is greater than 4 million. Z equals 0 and a equals, let's jump it out of the loop. A equals 1,000,000. And then it'll work itself out, hopefully. So, okay, and then x is 1, so x equals y, and then y equals z, and then repeat the process. Okay, so I think this might be okay. So let's log z, or let's log the sum, actually. I think it's probably better. Actually, let's start with z, and then the sum. So we're just checking stuff here. Logging the z. Sounds like a Little Mermaid song. Logging the z. Anyway, all right. Okay. All right. So let's do this for all the Fibonacci numbers less than. I'm using max now. Less than, let's say, what's some number that's reasonable? Let's go for 100. I think there's only like 10 or so below that, and then we can check the answer. Just go log z bunches of times, and the last thing it's going to log is the sum. Okay, Thanks. Sum. Okay, cool. So let's log sum. Sum is sum. Okay, let's see if it worked. Okay, here we go. The moment of truth. Dun dun dun. Okay, okay, hey, cool. We have some Fibonacci numbers. They are correct. I happen to know a few of them. And then the sum is 44. Let's see if that's correct. 2 plus 8 is 10. 44. Yeah, hey, looks good to me. Now we get to make the max not 100, but 4 million. So let's try that. 4 million. I'm pretty sure the no Fibonacci number is actually 4 million, so we don't have to worry about like equals. But technically, I think I might have programmed that part wrong. Okay, so you gotta like, not many. Oh, here we go. Here we go, here we go. Let's look at what we got here. Sum is this. Let's hope this is correct. It worked for less than 100. Really? That's very annoying. Yay, I got that one right too. All right, good. So, a little more confidence. Let's see if we can get the next one. So back to archives. Let's see 3. Largest prime factor. Oh, I'm pretty sure ChatGPT is gonna get this one right. But you're not helping my confidence here. All right. Anyway, let's paste in the problem. Oh, actually, let's save this first. This is Euler 2.html. Let's what are we doing here? Oh yeah, we're pasting the problem. That's what we're doing. All right, so let's do that. Okay, so let's see this. I accidentally like copied incorrectly. Let me change all these dollar signs into something else. I don't care about those. I'm just gonna make that one a dollar sign. Oh well, technically this one needs to be changed. Finding prime factors. I mean, there's brute force. And we only need to check up to the square root of the number. Question is this number bigger than what JavaScript can handle? Well, it could be, that could be a problem. I am just looking at it now, the number, and seeing if it's divisible by 3, just because. Nope, not divisible by 3. All right, I figured not, but hey, I just checked, right? What else? All right, so here's the statement of the problem coming up. Calculate needs to be reset. Okay. And here we go. Ready, set, refresh. Wait, did I not save it? Oh no, I edited the wrong thing. Oops. Okay, I edited the wrong file. That's never good. Oops. Is that really loud, by the way? Because I hope not. Anyway, let's close this thing. Let's come to here and paste. I expect something like that to happen almost all the time because I'm not good at dealing with multiple files with the same basic names. So, you know. Let's see. Let's get rid of all the calculate again. And let's start on the next problem. Ready, set, reload. All right, so. No? Did you get the right answer? All right, so let's see if this number here can even fit in JavaScript. All right, let's see. Do I need to make a like A library for very long integers. Okay, so let's just try to say a equals this. A plus 1. Let's logs it. Logs a plus 1. Okay, so a equals the number that they gave me. I'm going to try to log out a plus 1 and see if that works. Oh, okay, so JavaScript can handle it. That's good. Well, then we can just use our normal. We could brute force it, I guess. Like really brute force it, or we could just like try to come up with factors. Yeah. Huh. Let's really brute force it because I just don't feel like writing a lot of code for this one. Okay. All right. So we have a number a, and oh gosh, that's hilarious. All right, so let's brute force this. Let's try anyway. I don't know if it will work, but okay. So let b equal the square root of a. B equals the square root of a. Let's do the math floor, although it doesn't really matter technically. Math floor, math square root of a. Okay, so that's what b equals, and then b minus. That's a great problem though. Great response. B minus, b greater than 0, sure, why not? Let's have positive factors, maybe even just b greater than 1, that'd be great. Although we should really get to the answer way before that. Let's see. Yeah, so how are you doing today, Bellum? I'm having a great day. I'm doing math problems. Let's see. If a %b equals 0. Is that true? Pretty good. Been learning Home Assistant with a bunch of new Zigbee bulbs I got. Is that a sentence? I don't know what you're talking about. Thanks to tell me about that. I don't know what you're talking about. Is that like a response that you got from like ChatGPT 1? I'm like confused. Logs. B. Okay, so I'm going to list out the first, let's list out the first 10 factors of this thing. C equals 0. C++ here. Ooh, I get to use C++. Okay, anyway. Okay, so then if C is greater than 10, I see your message. I'll read it in a minute. Sorry. C is greater than 10. B equals 0. And that should jump me out of the loop. And it should display the first 10 factors, the biggest 10 factors of A, which is the thing that it hopefully entered right. So yeah, so let's see what happened here. Ready, set, go. Uh-oh. It didn't display anything. Maybe I should have tried like a smaller number first. Let's try that. Oh, wait, no. C equals 0. Okay, that's fine. Dear. Oh, I know what we're wrong. I missed a parentheses. But let's try a small number anyway. What's something with a big factor of some? Let's just try 1001. Okay, give me one more second. I gotta try this. Okay, good. we're good. My factoring thing works. Okay, let's see. Home Assistant is hosted home automation software. Oh, I see. Okay. Zigbee is a wireless home automation protocol. Okay, cool. Do you like actually like make the software for the hardware of the home automation stuffs? Like I don't know what you do actually, so or is this just for your own like edification? Like you want to get your home to be, you know, synchronized, which might be very dangerous if the AI takes it over. I'm kidding, but yeah, we don't talk about that here. I'm kidding. All right, so let's try a bigger number. 100300301. Let's try that number. That's a fun number. Okay, that's cool. Okay, I have this number that is 1001 cubed. So the biggest factor should still be 13. Unfortunately, there's other factors above it, which is kind of interesting. So I'm using some heuristics here to solve this. This is not a algorithm that always works. So let's see what happens here, though. So these are the 10 largest factors of. Oh, I should display the number that I'm factoring, just because I'm not factoring the original number. Just putting some comments in the math. All right, so let's try that again. Reload. Here, factoring this number here, which is 1001 cubed. It's nice. And yeah, I don't think you want that. Okay, so I can factor big things. That's good. Let's see what happens here. So what I'm going to do is factor this thing, and then, oh, actually, that's true. Those won't necessarily be prime either. That's okay. We'll figure it out. Yeah, okay. Wait, what was the original question? No. Where's my original number? Here it is, 6, whatever it is. All right, let's try it again. Okay, everybody, cross your fingers that my computer doesn't like completely like, malfunction. Let's go. 71 is definitely prime. That one I know is prime. But I'm not sure if these other ones are prime or not. So let's factor these one by one. The cool thing here is yeah, okay, so let's just copy all these. So I know 71 is prime. So 71 is the lower bound. But all these other ones could be prime. We should just check them out. Let's make another text document so I can keep a list of these on another page. So let's start with the biggest one, 48, whatever it is. Okay. I like my terminology here. 48, whatever it is. Okay, let's see if 486,847 is prime. Ready, set, go. It is not prime. Okay, interesting. All right, so that's not good. Now 104441. Let's see if that's prime. This is a bit of like brute force after a bit of computer help. And is it? It is also not prime. Okay, so let's keep going. 55969. Let's not do this by 3. Oh, well, I knew that already because the original number wasn't divided by 3 either. Let's see if this one's prime. Okay, so that one's not prime. All right. Let's try the next one. That one is prime. Alrighty. Actually, I think I messed up a little bit. No, I think that's right. All right, let's just in case, let me add one to the square root because I want to make sure it's not like a perfect square of a prime or anything. So let's try that. Yeah, it gives me the same response. All right, so it's prime. So it's prime according to what I know. How much stuff do you have to set up? Just wondering. Like, did you buy like the whites? Did you buy the hexagons? Those are sort of kind of cool because they're very expensive. And let's head back to Project Euler and hope that I got the right answer here. Booyah. Yes! 3 right in a row. That's always good. All right, cool. Next. Okay. Maybe I shouldn't be so, what do you call it? Glad that I can solve some of these. Palindrome, okay. Find the largest palindrome made from the product of 2 3-digit numbers. Okay. Well, that seems not too bad. There is a reverse function in JavaScript, so that's kind of cheating. But, I mean, you know, there are mathematical ways around that too. Okay, so let's go here, let's save it. 3.html. And then let's close it so that we can correctly edit the right page. And then we'll do this. All right. Let's get rid of calc.it because it's from the last problem. Let's save, let's move, let's refresh, and we have a bunch of $signs everywhere. 10 bulbs for now to replace my old cloud-based. Oh, okay. Wow. Oh, God. So what you're saying is, I doubt it was gonna hack you, but if someone hacked you, they could change your thermometer, your security system, and your lights. Oh, that's good. That's good. Yeah. Beware, ChatGPT may hack you. Yeah. Sorry. Let's not go to that. That's dangerous territory. Hey, you know, maybe the robotic consciousness will be very benevolent and very positive. Like someone might try to break into your house, and the vacuum's gonna trip it up, and then they're gonna make the thermostat like really high, and then they're just to piss off the guy, and yeah, you know, and the security system will go off and tell someone to help you out. So who knows? It's like, who knows? Maybe we'll have benevolent AI. But anyway, all right. Okay, let's see here. Whoop-de-doo. Okay, we're coming up to an hour. I'm going to finish at least this problem and maybe one more, and then I think I'm going to call it a day. All right, so palindrome stuff. Let me think. I mean, I just changed it to a string and compare the first and the last thing, and then yada yada. Let's be really lazy about it. Okay, so zero a. There's probably like a really slick way to solve this one actually. Now that I think about it, but I do not know what it is. So we're gonna brute force this one. So first for A, okay, and then for B. Actually, let's start A at 999 because I want to start at the high end. And then B starts at A and comes down. So B is A, or actually A next one. Well, actually, could it be a square? Is it possible for a palindrome to be a square? And the answer is yes, because 1, 2, 1 is a square. Okay. So B equals A. B is greater than 0, B minus minus. Okay, so I've got some candidates for in B. I need their product, which I'm going to call very creatively C. And then I'm going to see if C is a palindrome. So yeah, if okay, so C equals not A plus B, but C equals dash plus A times B plus dash. So I'm going to see if it's a palindrome by making a string palindrome and then testing the string palindrome, which shouldn't be too bad, I think. I'm actually going to do another for loop because I'm a terrible programmer, that's why. Alright, so D is less than C down length. And I know D doesn't have to be the whole length, but I'm just going to be lazy. It's going to run half as fast. But anyway, D is 0, D less than C dot length. D plus plus. Okay. So before this, I need to set a flag type thing. We'll call it isPal equals 1. And if C dot character at A does not equal C dot character at, it's not A. I messed up the variable. Okay. C dot character at D, C dot character at C dot length minus D, I want to say. That's probably right. If C does, oh yeah, and then isPal equals 0. And actually we need two things to happen here. Actually, I probably could have just used the flag on D, but okay, whatever. So the palindrome is true, is definitely not true anymore, so it is pal 0. And also D equals C dot length plus 100. Like, it doesn't matter what that is, but okay. So it's longer than C dot length. Jumps out of the for loop. The isPal part is not true, and what I'm going to do here is if isPal if isPal equals 1, I should just put true. I don't know why I put 1. I'm just used to like C programming or something like that. If isPal is 1, let's just return it. Return C. C is plus C plus semicolon B is plus the value of B plus the text is in semicolon A is plus the value of A. Okay, let's see if I can format this so that the spaces are correct too. Why not? Okay, so right now we have it going to 999. Let's make the max something else. We'll just call it max. And we're just going to do it for 10. Actually, what was theirs? I forgot what the original one was. 2 digits. Okay, yeah, so 2 digits. So 99. All right, so let's see if it finds the palindromes for the 99 thing. So it says max, okay. A is greater than 0, keeps subtracting stuff from A. Okay, B equals A, okay, that's fine. B is greater than 0, B minus minus, okay, that's fine. And then C is equal to this. Let's put parentheses here just in case. I don't think I need them, but why not? Then after you multiply A and B, we have a Boolean type variable thing called a flag called isPal, and then it loops through the characters of C and if things don't match up, it negates the ispal, and it jumps out of the loop that checks if C is a palindrome. Then after we loop through that, if there is a palindrome still, then we just return stuff. Oh, but guess what? I don't want to just return stuff. I want to like display it to the screen. So let's do what was it again? Logs of that. Okay, so let's see if it works for 99 up to 99. Let's see. Okay, so here we go. Let's go to the web page. Right click, reload. Okay. It did not do something good. Okay, so mistake somewhere. Let's log C. Actually, I don't want to log it. Oh, yeah, I do, but I want to do it this way. Where is outs? Outs. Okay. I just want outs to be C. Okay. Okay, so it's 1. I believe that is correct. Okay, so my palindrome thing is not working quite right then. Okay, but the problem is that really is a palindrome, so what have I done wrong? What have I done wrong? This pal equals 1. Okay, let's separate out the palindrome code, and I think that will probably be a good thing. Alright, let's separate this out. Function pal. I am just great with my names. Alright, so anyway, let's see. Pal C. Let's put in C. What's that HTML equals in C? I know, I'll just do that. That'll work. Let's see. C, okay, so this will be like in C. This will be pal in C. Okay, cool. So now the C's are fine. Okay, let's comment out the calculation one and just test the palindrome part. So it's a string. What is a good string that is a palindrome? Dash 121 dash. Okay, that would supposedly be a palindrome. And when I run this code, what's it supposed to do? Outs in HTML equals C. Okay. And it does this stuff. It says ispal is 1. Okay. Ispal is 0. Okay. For D equals. Okay. So yeah. So what I want to do here is outs dot just logs. I think logs of C dot character at D and plus a comma plus C dot character at. Oh, I need to subtract 1. I think. Is that what the indexing problem is? It might be an indexing problem, I think. The first index is 0. And the last index is -1. Okay, so that I know what well, let's do this anyway, see. We'll practice debugging. Minus D minus 1. I think that's what I need. Alright, let's practice debugging. Okay, so let's see what this does. I have no idea why what my output was just there. Okay, so it's got logs. It's got output C. Okay, cool. Then it outputs the first character C, Okay, and a comma, and the last character is C. Okay, we get it. All right. So I was off by 1. Drat. All right, so let's change this, and let's hope this works with the function. Okay. Don't need this anymore, I hope. So let's comment it out. What else? Okay, so it's a palindrome, log it, and return it. Oh, but that won't jump out of the right function. Let's just copy everything back. Alright. Let's see. So if we got this pal ink thing, just do this and change ink back to C. And I think we might have something to go on here. Okay. Calc it. Am I doing this right? Alright, let's try it again. Ready, set, go. C is 9009, 91, and 99. And guess what? That's the right answer. Alright, let's just, so checking out chat. Hey Sigma, how's it going? Yeah, okay. Okay. Alright. So, yeah, how's it going, Sigma? I will try to show the code. The code is really basic. My computer is very smart, so therefore I can write terrible code and brute force a lot more trials, I guess. What's the right word here? Anyway, yeah, I'm on it. This is good. Okay. So did the 2D one, no, not the 2D one, the 2-digit one, and let's try 3 digits. Let's see if it's quick. Booyah. Yeah, well. But B is not 3 digits. That's not good. Oh, I see. I see where the problem is. Okay. So B is greater than 0 is not correct. B is greater than 99, or just 100. It can't be 100, can it? That would be crazy. If the answer is like 100, 100, and 10,000, that would be pretty crazy. So I'm just like B, well, let's be greater than 100. All right, whatever. That case shouldn't be a problem. Let's try it again. 583 and 995. That looks good. Can I believe it? Maybe. I wonder if this is right. I trust my computer, I guess. Check. Is it wrong? Ah, it's wrong. What am I gonna do? There's a website that lets you check the answer. Yeah. It has a check button. Sorry, that grow. I hear a lot about Python, that it's very mathematical, but I'm like, yeah, no, sorry. I only know like one language well enough to do this kind of thing. So, what did I do wrong? Oh, I know what I did wrong. It might not be the largest palindrome. Okay, let's make a counter. Oh, I guess we just keep the max. Let's make a counter anyway. Counter equals 100. And actually not 100, maybe like 25. I can handle that, I think. So counter equals. I apologize for my coding skills, but I just let's see. So if it is a palindrome, counter, or what did I call it? Counter, yeah. Counter plus plus and So I'm going to list the top, not the top, the first 25 palindromes it comes up with. And hopefully... Yeah, okay. Let's hope this works. My brain is starting to fuzz up. Reload. Okay, that can't be the only one. Alright, so something went wrong. Gee. It found the 2-digit one fine. Okay. Let's see, counter 0, counter plus. Let's put parentheses around this just in case, but I don't think that's what the problem is. Oh, it's the return problem. Okay, I see. If counter is greater than 24, let's say, then return this stuff. Otherwise, just log it. Okay, I see. Counter is greater than 24. Alright, let's try this. Yay! Bunch of numbers. Oh, there's a 906609. That's pretty large. Yeah, so that's the biggest one so far. So we're just going to do this if the palindrome is greater than 900,000. Wait. Yeah, 900,000. I can't think. Okay. A times B is greater than 900,000. Hopefully that'll be a good enough lower bound. All right, let's try this again. Go. Oh, only one. And we found it. Cool beans. Okay. Okay. Yeah. How long have you known Python? And like how much sort of how much experience do you have with it? Yes! Check mark number 4. We're good. Okay. Let's try to do one more. And then we'll see what happens. Minimal multiple. Okay. Oh, that's really easy. I can do that on paper. All right. But let's copy the problem and save the palindrome one. Let's come here and paste in the problem. Ooh, they use class tooltip. How very modern of them. Okay, sorry. JavaScript has gone through so much, and HTML and CSS has gone through so much changing that like it's just funny. All right, so let's see. Is this gonna work? Yeah. Okay, I don't know about the formatting here. What happened? Oh, I see. Okay. Let's remove some formatting so it looks correct. Let's put star instead of the crazy stuff they want me to format with. Kind of thing. All right, let's try that. What is the smallest positive number that's evenly divisible by all the numbers from 1 through 20? Okay, that shouldn't be too bad. I can actually do that on paper probably, but it might take me a while to do the multiplication. So, paper and a calculator. Yeah, this one should be fine. Let's solve it by hand. Why not? Let's see. Where's my pen? Let's flip this upside down. Okay. So we got one. Oops. Come on. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so all the primes I have to underline because those have to be. Oh, actually, no. All the primes that are greater than 10, I want to say, have to be underlined because they have to be taken into consideration. Oh, I'm just looking for the highest prime powers of any of these numbers. Okay. So, 5 has 1. So let's just underline that one too. 7 does not have a 49, so let's underline that prime number. And that is just 3 and 2. 3 squared is 9. Okay, so we need a 9 here, and 2 is 16. So let me just count up the number of primes. 1, 2, 3, 4, 5, 6, 7, 8. I want to say there's 8. So I should have 8 underlines here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. And then we have to multiply all these crazy things together. So let's start with the easiest ones, or let's just use a calculator. I'm not gonna. Okay, cool. Let's just use a calculator. Easier like this. I'm gonna mess up the calculation, I'm sure. Oh, no, okay. 17 times 16 times 13 times 11 times 9 times 7 times 5. Holy, that's not a small number at all. 232,792. Yeah, okay. We have the same number. Let's copy and paste this thing. And let's see, where's the check thing? Here. All right. Yeah. Please be a check. Yes. All right. 5 problems today. That's not too bad. Some of these problems are really hard, though. I shouldn't say, like, I shouldn't pat myself on the back too much right now, because some of these problems are very, very difficult. But yeah, I got through the first 5, so I am pretty happy with that. I think 5. Oh, let me say this one first because I don't want to forget to. I should at least, I guess, put the answer here. And then I'll put in parentheses by hand / calculator. Okay. And then, yeah. And I think I'm going to end the stream. I have someone in mind that I want to raid. We'll see if they're on. Give me a second. By the way, wait. Oh, you were from that crowd. Is Shock Attack still on? Let's see, Shock Attack. All right. So I'm probably gonna raid them. Hold on. I don't know if there's gonna be audio here. I apologize if there is. It might be loud. I apologize. Let's see. Okay. All right. Yeah. So she's still on. Let's go. Okay. Well, I'm gonna raid in just a second. Let's see. And so, raid, Shock Attack. And let's hope this goes well, because I have no idea. I'm having some trouble with the interface here, so we'll hope. Okay. Raid, Shock Attack. Let's try it. Oh no, it won't let me. Hold on. I have to do it on another device. Just give me a second. Okay. Spelling the name again. Oh no, the channel is intended for mature audience. Okay, forget it. We're not gonna raid. Okay. All right. Thanks guys for showing up, and I'll probably be back later. When later, I don't know. Maybe tomorrow or the next day. Probably once a day. All right. So thanks for coming, and enjoy your evening, morning, afternoon, late night, and I'll see you guys later. All right. Take care, guys.